relatively similar to when we did it. This is a pretty difficult exam coming up, but cool. Overall, we do have some pretty good information to cover. I am going to grab my notes and get everything prepped, but if you guys have like a specific question that you want to like start right off rip, like if you want something re-explained, or if you need something, I guess, answered. If I don't know it, I can certainly look it up here. Something that they want to start off with. Okay. So just kind of coming here to get like a general, was anyone here last? No. Okay, cool. So coming here to just kind of get a general aim of like what to expect. My question for you is, how comfortable do you guys feel on cross sections? Like if, I guess, like if we draw a brain, a weird brain, how confident do you feel in like, so there's 3 different cross sections. You know what they are?
Yeah, this is down the.
Do you know the names of them?
No.
Okay,
But
cool.
was it one horizontal?
Yes, that's the easy one. Horizontal, think of it as a horizon. It is just kind of a flat line that comes across the brain. You can think of it like literally you're looking off into the horizon and it's just one long flat intersection across the brain. Another one, this one is the next easiest to remember. So there's 3. There is horizontal, sagittal, and then transverse, or I think there's, you can call it coronal, I think, let me double check. I call it transverse. Normally, that's what we do in anatomy, but either or should be okay on the test. Sagittal is really easy. It is right down the center of the face. Sagittal is pretty easy. It's like right down the center of the face. You can think of it as splitting the right and left hemisphere in 2. So I'll do, just write them down. You'll come to know that I also suck really bad at spelling. And then transverse is kind of the funky one here. So if we have our brain, we can think of transverse as a front half of our brain and then a back half. So it comes down, like if you're looking at me, it'll kind of like cross section front half and the back. So I don't know how to draw this really well, but if I, oh, cool. We can just use this picture again. I'm going to put this down. You can also call that coronal. So either or should be okay on the test. I'm not too worried about like which term you're using or if it's correct or not. Well, I am concerned if it's correct or not, just whichever one you can remember best.
Let me draw something.
Yeah, of course.
For the coronal plane. Let me draw that.
That's exactly what I thought.
Yeah.
I was like, damn.
Or no language.
Are you gonna do the, yeah, that's exactly what I was thinking too. Sagittal.
It's like to the side, if the brain's to the side.
Oh,
Right? It's like coming from like
back.
the ears.
Yep,
The
so
front's in the back.
transverse is front and back, and sagittal is right and left.
Oh, genius.
Okay, so this is what the like cross section looks like for the like coronal or transverse, right?
Yep, both.
These are like ventricles, right? I think so.
I think that,
This is something.
I think that's the substantia, maybe.
Let's see, on my 3D.
I might also have a different cross section, maybe. But basically, as long as you know, like, kind of the general, where is it cutting, where is it separating? You know that, sagittal is your hemisphere, so you can kind of think like, oh, if I pull my brain in half, you'll have a left hemisphere, right hemisphere. Horizontal is kind of like just, if you cut your brain like straight down that horizon, like right down the middle, kind of like this. That is the horizontal one. And then, of course, the transverse or coronal, it's going to be like your front and your back halves. Any questions upon that, or just any further explanation needed? Otherwise, we're just gonna keep chugging along. He also talked about neuron tracks and fibers, right? Nerves and tracks, the difference between them.
Oh, we're talking about today.
Oh, cool.
Like 2 seconds.
Yeah.
Yeah.
I was like at the very end of the.
Okay. Do you guys remember which is which?
I do not.
Okay.
What's the
Cool.
question? What is the between nerves and tracks?
Yep.
Um,
So, this is one that I think do you remember? I think this was
There's
something
tracks and
that-
like ganglia. Is that what we're talking about?
Yeah, so do you remember if it was on the exam? Because I think it was.
Yeah, it's on Ronald's Quizlet, so
Cool.
I'll say it's on the exam.
Awesome. So, nerves are basically a collection of axons outside the CNS. You can think of this kind of in relation to the peripheral nervous system. So, like, if I have a nerve that is kind of allowing me to feel something down by my fingertips, those nerves, they aren't connected to the CNS. The CNS is central nervous system, your brain, your spinal cord. Peripheral nervous system is all of the nerves that are kind of like spreading out through the rest of your body. They're kind of like your senses, sensation, also with the motor neurons as well. So as for, let me double check here. Yes, nerves are basically a collection of axons outside the CNS. So those are all going to be like around your body. And then tracks are a collection of axons inside the CNS. So oftentimes you can kind of correlate these to white matter tracks inside your brain. These tracks are kind of what allow for intercommunication between different parts of the brain hemispheres. So like if a brain is talking from one side to the other, the corpus callosum itself is made up of a lot of tracks. It's very, very highly dense in that white matter. That is an important thing to know. And I'm gonna keep chugging along with
Yeah,
the
write it
idea
down.
of white matter. So I also want to make sure, did he talk about like where white matter and gray matter are and like kind of the difference between them?
in the spinal cord, they're like switched from the brain.
Yes.
So is it like gray matter in the spinal cord is like in the innermost and then the white matter is like the outermost and then reverse for the brain?
Yes. So for the brain itself, the reason why it kind of has that like gray tingy hue is because the gray matter is on the outside. So I'll just chug along to which gray are we going to use today? So for our brain, that's again why it looks all gray and kind of like disgusting. And then another good way you can remember, which, what do we have gray matter or white matter on the outside of our spinal cord? You can think spinal cord, it's a bone. It's like kind of covered in bones. So I like to think that, the white matter is kind of more correlated to the white color of our bone, while the brain is kind of a little more like tinged, hued gray. So we'll do spinal. And gray matter on the inside.
You think that he'll ask us like what it does instead of where it is?
That's a possibility. I'm more confident than he'll ask like where it is. But if you have to like really know what it does, you can think that like white matter is white because it contains a lot of myelination on it. It's basically white matter tracks are very, very myelinated, so it sends those signals and intercommunicates really fast. While gray matter is basically kind of cell bodies, more or less. They communicate information not so fast. And then if you want to talk about ganglion, I feel like you might have a better understanding.
Honestly-
That's okay.
Were you all here for yesterday's? No, okay, so. Okay,
I can also go.
other than like the definition of a ganglion being collection of cell bodies outside of the central nervous system. Let's see, what else do I have? But then, we did talk about this yesterday, that the basal ganglia is not actually ganglia. Those are nerves, right? No, those are,
Basal ganglia
yes,
is a collection of nucleus.
a nucleus.
Yes. We'll cover that shortly here. I just want.
That's also on the review sheet I posted.
Yes. So,
What?
It's a collection of things.
yes, a collection of nucleuses. We'll cover it in more depth in a second. We'll draw it out and everything so that you can get like a good picture and representation.
He said he'll figure it back to me, so
Okay, like today or like?
I don't know. It's a good question.
Okay.
I would
Sounds good.
email him.
Any questions still on like this concept of white matter, gray matter, where they are, what they do? I'm just gonna try to like cover some of the base stuff and then we'll kind of slowly get to the more complicated stuff as time goes on. But really, I want to focus primarily on questions that you might have. So like if you have a question and you're like, dang, this really does not make sense, or man, Noel, what the hell are you talking about? Please interrupt me. I really sometimes get lost in my own thoughts. So. Perfect. All right, so we went over nerves, tracks, white matter, gray matter, and planes of the brain. Let's see. Is there anything that you guys talked about that you really want to like dive in depth? Because that helps me like get on to like a stretch here.
Can we talk about like specifically what the reticular formation
Yes,
does? So I feel like it has a lot, there's a lot that goes on.
yes. So the main focus and takeaway from the reticular formation is it helps mediate and like tune out certain information from your surroundings. It tunes out certain sensations. So for example, if you hear a tapping noise coming from somewhere, if you hear it for long enough, eventually your brain will be like, okay, this information is not important. and it will start to tune it out. This is also kind of important because if you think about people with ADHD, people with ADHD have or can have an issue where with that reticular formation. So oftentimes, I don't know if you described it as this, but they will rock as a way to kind of like, oh, yes. Autistic individuals will rock to kind of create this like repetitive sense so that they will remember or kind of like be able to focus their ire a little bit more. It helps them kind of like set that pace rather than, you know, not be able to tune out information. That helps them attenuate and focus down onto that. So,
Is that?
yeah, it is basically in that brain stem area. Really, all that you would really have to know is that it pretty much just tunes out in unimportant information that is repeated.
There's three main functions.
Yes.
So the sleep cycle, your level of arousal and selective attention, kind of going back to,
Yes.
there are some about ADHD, but I forgot.
It's hyperhabituation.
Yes.
something.
Yes, the level of arousal, again, not sexual arousal. How would you explain level of arousal? I'm always marvel at this.
Kind of the arousal of like movement or being able to like, hey, I want to get up, I want to do this. I'd almost kind of describe it as motivation. Arousal, you can kind of think of it as kind of like a, hey, I need to do this right now. Sleep, arousal, and attenuate or habituation,
Attention.
attention.
Yeah, selective attention.
See, okay. That's a good example of that, selective attention.
Yes, so with selective attention, that's that habituation progress, yeah.
Are these two things we're just talking about, so I was a little confused, like what it like does, it regulates in a sense, or what is like the sleep cycle, what did you do?
Those are the three main functions that it's part of.
Yep.
But
So,
also, you'll find that other parts of the brain are also involved in your sleep cycle, attention, you know,
Yeah,
but this is what.
got it,
Yeah.
yep, so there are a lot of parts of the brain that also focus on some of these topics as well. You'll kind of, the more you dive into brain anatomy and physiology and more stuff along these routes, everything is kind of just intraconnected. There are things that have some specified uses, but oftentimes, you know, it is kind of just a global process throughout our brain and connections everywhere. So somebody mentioned the word habituation. That really goes hand in hand in the selective attention. So the way you can think of selective attention is, hey, I'm choosing to attenuate, or I'm choosing to listen to, I guess, my voice instead of that tapping noise. The longer it goes on, you'll basically habituate out the tapping noise. That's kind of the getting rid of it from your own perception. And that's something that the reticular formation can do. Hyperhabituation is when you're unable to tune that out. And that is an issue that, you know, you constantly hear that tapping noise and you cannot focus. What else here for the reticular
I was gonna bring
formation?
up the oddball paradigm.
Yes, that's it.
With that tapping example, I don't know how to explain this. You're probably gonna be better at
I
it.
got you. So, same thing with that tapping example. Your reticular formation will tune it out eventually. So if it keeps tapping, and it's keep tapping, eventually you'll stop hearing it. But say one of these times it's a lot louder than usual. You're like, oh, now all of a sudden I hear the tapping again. Now you're kind of like, oh, I can hear that. You want to draw out like a wave
Yeah.
of that we did last time? Yeah.
Is it like, so you get this tapping noise, and then you tune it out, and then something triggers it to get louder, and then it comes back to the fix? Is that what it is, or?
It's
Yeah,
like,
so it's the oddball in that thing, it stands out. It will kind of like, your brain will tune it out as it becomes repetitive. So as long as it's not changing, your brain will kind of be like, okay, yeah, I've heard this already. I don't need to hear it again. But as soon as it's louder or it has a different tone, a different pitch, something that makes that sound stand out from all of the previous information that it's been gathering is what I would consider the oddball. You can kind of think of, it's the oddball, it's standing out from the rest of the sounds that you've heard. This can also be true for any sensation, but most of the time it is auditory.
We'll usually only use auditory examples.
Yeah, there are some visual examples, you won't have to know them, but I just want you to know that like any form of sensation is true to this same example. One way to kind of get you to also think about this in a different type of sensation is how many of you felt that you were actually sitting on a chair until I just mentioned it? Now can you feel that you're actually sitting on the chair now that it's kind of like, oh, now that I brought it up, now it's in your attention, now that was the oddball, me bringing up the feeling of the chair. Now I've kind of reconvened this feeling, hey, I'm sitting in this chair. This is what I'm feeling now. So that's a really good example of, I guess, selective attention, being able to tune that out. Or like, I'm wearing socks right now. Sometimes, I guess it depends on the type of socks that you wear, but
So
normally I don't feel my socks or pay attention to that.
I was gonna bring up the orienting reflex. So like, okay, if you're in a quiet library and then somebody screams and your head, moves where you scream, that's kind of the orienting reflex. When you get that oddball paradigm of something new happened, a new, again, usually auditory stimulus, your head within instincts turns. That's kind of what that is. I don't remember if it's on the test, but I remember he mentioned it.
Reflexive attention.
Yeah.
I don't really know if this is related to the particular information, but today he kind of talked about like caudal, meaning like sleep, and rostral, like wake, like kind of like this.
Oh, sleep
Wake
cycle.
cycle.
If you give information, if you lesion one end, it causes that. If you lesion the other, it causes that.
Which
So
one's
like,
which? Like when you're looking at it.
costal's tail, so it's the very
Yes.
end of it. And that one is, I don't remember, but rostral is the top.
So rostral, like you, like really lesion it or whatever, then you just like sleep all the time.
Somebody had.
So that is in reference to a study somebody was doing where they had an animal went into their brain. If you put electrical activity at one end, the caudal end, the animal would fall asleep. And rostral, and the rostral end, if you put electrical activity here, the animal would be awake.
Versus rostral. Caudal is like down or the back of the brain.
And like rostrals, like like.
Your face.
Oh.
And with the body, there's different words for it. I'm honestly okay if you use anterior or posterior as well, if you've taken anatomy. It means the same thing, but ventral is your front and dorsal is the back. You can think like a dorsal fin. That's kind of how I also try to remember it. Caudal, yeah, tail, and rostral being the front of your face. Are also good ways to remember those specific anatomical terms. But again, if you use other examples like posterior, that's also another way I remember, like, it's my back, it's my posterior.
Also, if you put just towards the back, like you should know the terms, but if you can't remember and you just put towards the front, towards the back, I don't know what you're talking about. Unless he's asking, what's the term for this?
Yeah,
But
I do know that there will be probably a few questions where he's asking, like, to display your knowledge of those anatomical terms.
Mhm.
So for example, one that I remember from previous year's exams would be something like, oh, my fingers are what anatomical position to my elbow? So they would be distal as opposed to medial. Medial is your midline, your center, and distal is like how far distance away from that body is that. You can also think of like, oh, my head is superior or up. Superior as being like someone who's above me, to my feet, or my feet are inferior or down, towards like my chest. It'll be something like that. I don't think he'll use specific like brain terms to refer to it. He could, I don't know, but at least in the past years, he's just used something like, you know, my finger to my elbow. My finger is farther away, therefore it is more distal, more distance away from my midline, which would be medial. Any more questions?
I'm sorry, could you go over the things again? 'Cause I'm just looking at my notes and I'm just getting confused. Can you go over the like posterior, anterior, the rostral, because rostral is the same as anterior, right? Or,
Yeah,
Close?
so there's a bunch of different words that you can use, and it all depends on which words you want to use. It's basically rostral and caudal typically refer to the head
Okay.
itself. So I'll turn this picture around for you as well. That is kind of like where I would refer to the head.
so those terms are mainly used for the head and then the rest are kind of used for the rest of the body?
Typically, yes. That is where, like, if you get ventral and dorsal, that's normally like your body.
Okay.
And dorsal would be the back of your body, or caudal would be like the lower part of your
Okay.
head. So there's some funky anatomy. We don't typically use these nowadays in anatomy, but this is more specific to physiological development in the brain itself. So like, that's why we use caudal, and I don't even use them, so it's a new term for me as well, rostral. That's why we use them, is because it's more like specific towards the head. But overall, if you use anterior, which is your front, or posterior, which is your back, that's okay too. I don't care what function you use. If you use ventral instead of anterior, you'll still get the points.
Yeah.
It's the same thing overall. Is there one that you were like confused about, or do you want just like a list of all of them?
Well, okay, so I have like anterior, okay, lateral and medial.
Lateral and medial.
And then like, is this still the same as one of them? Or-
Yes.
Okay.
Distal is kind of the same as lateral. Lateral is, you can think of like your lats, or like any of it's out.
Okay.
Medial is middle. Distal is going to be like, oh, it's, you know, farther away, lateral out, distal far. Same difference. Typically distal refers to your appendages, while lateral refers to your body. Not a big difference if you use one or the other. It's the same meaning, just kind of more specific. It doesn't matter to me. I mean, if you put down, hey, my fingers are more lateral than my heart, yeah, that makes sense. It's not a big deal which words you use, as long as you're using just kind of the correct term.
Okay.
Personally, you can pick which terms you want to refer to, if you want the anatomical ones or if you want the physiological ones. Both is correct. I know other students also asked that same question, where it was like, well, which terms do you want me to use? Do you want me to use rostral? You can, or you can use the other one. I don't care. It's the same thing pretty much.
Okay.
Yeah, I'll just kind of try to remember it as superior. You're looking up to someone, like your superior in the office is above you, and inferior is below you. Anterior is front or rostral, also front in the head. Caudal is your tail or kind of back, or posterior is kind of the back. Ventral also being your body forward and dorsal being your body backwards. There's a lot of different anatomical
Yeah.
terms. There's too many. We should just pick one, honestly, but did that help? Or
Yes,
do you want like?
no, that was good. I think it was mainly like the distal means it distal, and I was like, I don't remember it.
No, you're good. See, that's
I
where
don't
it's,
remember bringing up distal.
it's probably an anatomy
Yeah.
one. I prefer the anatomy ones. They're just more universally used, in my opinion.
I wanna bring up one more thing about the reticular formation. So I drew those little arrows. So the reticular formation also decides which information is gonna make it to your consciousness. So like all those things that you're sitting in a chair, but you can't really feel it, you're wearing your shoes all day, but you can't really feel it. Those kind of things, it decides what's gonna be brought into your consciousness and what it's going to tune out.
Liam?
Yeah.
This is also a really good example of the oddball paradigm, where you can see we've got this stimuli, this tapping, and each one of these spikes is a tap. And the longer it goes on, the more it gets tuned out. And then this is the really loud tap, this big spike, it sets it back, and now you're still picking up that information again.
Does he like have it? It's like posterior and caudal, are those like interchangeable?
Yes and no.
I'd say so. I'd count it correct if you gave me that on an exam, but caudal again refers to particularly the brain and the head.
But posterior is like the position? Or like kind of like. the-
Posterior is like behind, where caudal means like tail. Like I remember he gives an example of an alligator, like its tail is caudal, its head is rostral.
Yeah.
Where posterior means behind and anterior means in front of. So they're like, they can be used interchangeably, but like, it's really minute differences. At least that's what I remember.
Yeah, they're very, very small, like specific differences,
Yeah.
but if you put down one, I'm going to count it, right? I don't know about you, but.
No, yeah, I really won't care, honestly.
It pretty much means the same thing, close enough.
Yeah.
There are differences, but they're only in specifics, which if you're grasping the topic, I don't care. As long as you understand what you're putting
Yeah.
down, and it's not just like, oh yeah, man, my feet, they are very, very, I don't know, superior. They're the top part of my body. They are superior. As long as you're not putting down something like that. As long as you're kind of like referencing it. Also, please do not say like medial or lateral. When you refer to like this, I could get if you were referring to like lateral position, because my feet are spread apart. They're wide, so they're not medial. But if I'm standing like together, this could be medial. But unless it's like giving a specific example where somebody's like spread out starfish, I would prefer to use like something that's like superior or inferior to another position of the body. I'm just going to try to exaggerate all of my body movements and see if that helps on. If you see me in enough weird positions today, then you'll maybe remember the anatomy terms. I'm also trying to find the specific picture that he looked up from the lecture that he used to refer to these anatomical terms as well.
I remember there's like a visual of it.
Dorsal's the back.
Dorsal, think
Yes.
of it like the dorsal fin of like a dolphin or something.
Yeah.
Towards the,
Ventral.
yeah.
Here it is. Yes, let's go. I knew exactly where it was too. Okay,
Yes.
this is not the greatest, as my computer is very little res. But again, dorsal is kind of like the back. But in example of an alligator, caudal is that tail area, where caudal for a human is going to be like kind of back and down.
Do you think we'll talk about the neuroaxis? or ask about it?
Your access.
Yeah, I have it as spinal cord going up to head, bends on neck.
I don't think so, but
I gotta-
kind of understanding that like, you know, as your spinal cord comes, it curves and comes up here.
Yeah,
It's just an important thing to know.
Just, yeah, it's like understanding where your brain and spinal cord are in relation to your body.
okay.
If you guys want to see the, I'll put it over here too. I'm showing as like that tail.
Is there any screenshot that you sent to me?
Yeah.
I can put it in the view.
The tail is kind of that hollow area where, the head of the alligator is very rostral. But like if you look at a human and some your face is rostral. But you can see kind of in like this axis, and you see how like this goes back and then goes down. That's that caudal end where it's going and turning down.
How do you Google it?
So, yeah,
There's a
that
ipsilateral
is
and
in reference to
contralateral.
like the head. So the dorsal of the head would be like
No.
superior.
Probably.
Yeah. It's like going over that.
Yeah, so
All have
if,
the same side of brain and opposite side of
That's
brain, but the
basically-
brain is.
It's-
And that's
yeah,
why
it's-
if you ever wanted to refer to like the back. of the head,
Well, okay.
that's what we use.
so there,
I feel like the brain is just.
that's why we split it into different, like the transverse, horizontal, it's just split into different sections. So when you're like really in-depth learning about what it is, they will have it in different sections, but like, let's see, contralateral, like the right hemisphere and the left hemisphere are contralateral from each other. They're on opposite sides of the brain. If you think about it like that. Whereas like ipsilateral,
Try to differentiate
like,
from the other ones, but that's not.
Like the right side
let's see.
is opposite of your left side. You know what I'm saying? Opposite.
That's all.
I don't know what I'm saying after the. I need to.
You know, there's too many, that's what I'm saying.
Hmm,
As long as you pick one of the.
I need them to give me.
ones, it doesn't really matter which one.
I like that one.
You know, it's the one that works for you. You can either do, you know,
That like's haunting.
anterior, posterior,
I can still see it in my brain.
ventral. Or you can do.
Yeah, it's just like, I think the brain is all around, so how can it be opposite side?
I
I think you have to think about it like,
Roughly that splitting of the head.
so like if you're
So
so
like refer to
vertebrae,
your
you're
body
splitting
as
sagittal.
It's talk about like how things are in relation to each other. Like he said, he was giving an example of like my fingers and my, but like, can you give me an example of ipsilateral? Cause I told them contralateral is like the opposite sides, where this is opposite from this on the side of the brain. I can't come up with two that are next to each other.
like, example of ipsilateral
Yes,
connections.
of something that's ipsilateral in the brain.
That's very confusing, because, yeah, I only have the same side, opposite side. of the
That's
brain, and
really
that doesn't have
all you
the-
need to know, really, but
So if you ask about it, just write that down.
if he's asking for a definition, yeah, just put that.
Okay.
He could.
Just put down same side.
For.
Yeah.
Ipsilateral.
Ipsilateral is going to be like the same, same side of the body or brain.
Yeah, like your right eye and your right foot are on ipsilateral,
Yes.
But your right eye,
and your left foot are contralateral, whereas like the left hemisphere, right hemisphere are contralateral. But I can't think of two things that are on the right side of the brain. That would be ipsilateral.
Your Broca's and your Wernicke's.
Yeah.
Did you guys cover the Broca's areas and Wernicke's? Did he like? talk
Broca's
about-
area, that's like your ability, like you can like hear what someone's saying, you just can speak it, right? Or is that?
Yes.
That's if there's something wrong with that part.
Yeah,
Yep.
but isn't the, whatever you just said, the Wernicke's area, is that the opposite where it's like you? I don't actually know.
It's the understanding
just
of
like,
language.
So like if you have damage to Wernicke's area and you can't understand what someone's saying, it just sounds like.
Yeah, pretty much. So your Broca's area, it is on the left side of your hemisphere, your left hemisphere. And Broca, yes, it is basically involved in speech production. If I have damage to my Broca's areas, which I do, surprise to surprise, not very big, but I do have damage to both of these areas. So that's a way you can remember it. Just be like, damn, my TA.
I'm just gonna write your name down.
But yeah, you can think Broca's areas. If you have damage to that area, you have trouble speaking. It is primarily with like not only finding the right words, but verbalizing it. So like sometimes my mouth will go into like random syllables. And this is so traumatic, but I was trying to give a presentation and I was trying to say, you know, primarily, but I kept saying pyramid over and over again, and it was the most horrific moment of my life. For an example of like Wernicke's, yeah, I was involved in speech production. So, that's Broca's. Wernicke's is understanding speech or interpreting information or comprehending what verbally or auditorily has basically come in. So if you have damage to the Wernicke's area, you basically won't be able to like comprehend what people are saying. You might be able to hear a word, maybe, depending on how severe that damage is. But it oftentimes kind of semblances it into the big picture. So like if you have damage to the Wernicke's area, you might not be able to like fully grasp what's being said or understand what the, you know, what the message is saying. It might just come out as a jumbled jargon to you.
Okay.
So if you have damage with the Broca's, it'll sound like blah, 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 blah. But if you have damage to the Wernicke's, you'll hear blah, 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 blah. So that's how I try to remember it. Luckily, I have very, very, very minute damage, but it definitely makes its presence sometimes.
Do you remember him having a picture of the brain and then like this side face slips and then it goes out to each part of your face? Do you remember that?
If you show me a picture, I'll probably be like, oh yeah, I remember that, but
Brain map.
also we'll try not to erase as much stuff, but
I'm
like,
taking pictures too.
yes. We'll be able to use that as like a good way to like, we'll take a picture and post it on Canvas in case you want to review it after the session as well. We're also trying to take a video this time. I don't know how well it's gonna work because I'm kind of doing a Bob Lloyd and not being on camera. But
I feel like we're talking loud enough and close enough to the.
that's,
thing
yeah, that's my goal too,
With
is
the
just
camera
be
angle.
loud.
At the board.
And Ronald will be back sometime this session, so he'll be able to help us out
Where
too
is he?
in a class. Any other questions?
Yeah, Ken, you go over, let's start with M, the meninges.
Meninges.
Yeah.
Yes. So there's three parts of the meninges: the dura mater, the arachnoid, and the pia mater. Let me pull them up here because I would like to remind myself before I tell you to make a fool of myself. Yes.
Yeah, that's what I remember.
So the dura mater is the outer thick layer of the meninges. Basically, what meninges do is they protect the brain from infections. They're kind of like a soft like coating. Think of it like a visceral sac.
Think of it like your skin layers, like they're
Yes.
protecting you. And as you go lower towards your muscles, they are different. That's amazing things.
I'll tell you a really fun fact about the meninges too after this. The arachnoid filaments, they are basically the middle layer. I know they have some, I know each of them performs some task, but I don't think you'll have to know those tasks. You just need to know the order, like which one is outer, which one is inner. And then the pia mater is the inner layer, and I think it's the thinnest. If that's wrong, then I'm just wrong.
You always the point on the exam.
So,
So
Um,
I don't know if they're actually, translated to these, but I have written down from last semester that Dura mater means tough mother and
Yep.
Pia mater means petite mother. So like, for mother and like protection.
Yes, it is.
Really? Wow.
Mhm. The delicate inner layer is the pia mater. The middle layer is known as the arachnoid, due to its web-like structure, and fluid cushion of the brain. And the outer layer is the dura mater, which is the tough, basically, I don't want to say skin, but covering of in between. So you can kind of think of it like there's the soft side, the web structure with a bunch of fluid that basically kind of cushions, and then really hard skin on top of that, or like covering, that is the dura mater. So from outer to inner is the dura mater. Outside, that's basically, yes, beneath the skull. The arachnoid is the middle layer. You can kind of think of this as, you know, all a web. It looks like a web structure. That's why it's named the arachnoid. And then the pia mater is the inner small thin layer that basically covers the brain. Very good question. I actually had that started. That was one that I was going to talk about if we ran out of questions.
I have a question.
Yes.
In class today, he was talking about the pairs of spinal nerves, and then in one of the slides, it talked about all of the pairs. Do you think we need to know those? Or can we just say like, there's 31 pairs of
Oh.
spinal nerves?
I mean, I think knowing the number is more important than knowing. I think that would be a little much even for this class. I don't remember him asking. He might ask like, how many are there? But I don't think that he'll ask like what, maybe he'll ask like what an example is. So if you know one, I can't necessarily say that I remember any of that. I didn't
Like,
take any of that down.
cervical, thoracic, lumbar.
Yeah,
I'm gonna be honest, I don't remember that, so you probably don't have to know it.
I'll say just kind of understanding that cervical nerves. You can think of the cervical spine, that's your neck. They also kind of come down to your fingertips, your head. Thoracic, chest area, so that's kind of, I should probably be on camera while I do this, cervical. The thoracic is the chest area that is basically, you know, thoracic, you think of your lungs, your thoracic cavity. And then your lumbar is oftentimes like your lumbar spine. So those are going to be like your lower, like your hip, your gut, kind of generally the nerves in your legs spread out from your lumbar. So if you've ever had like, I don't know how old you all feel yet, but if you ever like pinch a nerve in your back and you're like, I cannot walk, where it's just, it'll jet all the way down your leg. That's how I remember like where spinal nerves are. I'd say probably understanding like, I think there was a question where it was like, maybe this is an anatomy. Yeah, this was an anatomy exam. I probably I won't confuse you with that. But just kind of understanding, you know, your thoracic, cervical, lumbar, is a good way to remember that. Cervical, you can think of neck, thoracic is your chest cavity, and lumbar is your like flank, your lower spine. That is a good question. I can't say that that will 100% be on the exam, but I mean, if you're going into a related field of physiology, psychology, of anatomy, anything like that, it'll be good to know in the future.
He did kind of talk about cranial nerves at the end of class, but he was like really close to the end, but he kept going, so I think everyone stopped taking notes, but
Yeah.
Um,
Right.
like cranial nerves, he said that one is different, or like there's one nerve specifically that the rest.
It's sort of.
Vagus-
Oh, I
vagus
was
nerve.
gonna bring that up.
Yes.
So it's the only cranial nerve that doesn't go to somewhere in the head, and it innervates all of your peripheral organs. So your stomach, your heart, your skeletal muscles, or near that at least, all of your organs that just aren't your central nervous system, basically.
What's it
Red
called?
one, whatever that
Vagus
is.
nerve, VAGUS.
Well, it's like this, and what does it?
Starts like near the midbrain,
Doesn't it, it starts like up here.
by the thalamus.
Yeah.
Yeah.
Okay, so it starts somewhere up here and then like down your brainstem.
Mhm.
Might be-
Okay, so cranial nerves, besides one, all go to your head.
All to your
or
face,
All to
yep.
your face.
That's crazy. Like, trying to move my face right.
You have like 6 of them that control your eye muscles
Oh,
out of the 12, so
There-
half of them.
There was a scientist at like 1950s, I think, and he took the entire nervous system of a human and pasted it out on a board. Have you seen that picture?
Yeah,
Yeah.
So you could have to memorize all of them. Thankfully, you don't.
Yeah, I don't think he'll ask you like what the specific ones are.
no, it is just that one.
Yeah.
That's because he showed a picture of it and was talking about it, but it was like 1250 at this
Yeah,
point, so.
I'd say like, know the number that, like, how many cranial nerves there are, how many peripheral nerves, or, nerves there are. I'd say knowing that the vagus nerve is the big one, honestly. I don't think he'll ask you like how many,
Mhm.
but he could, I don't.
Sorry, I'm just confused on what does the vagus nerve do?
I was just gonna write that
it
down.
sends information, sensory information from your organs in your body back to your brain. I don't know if you went into this for you guys, but if you have damage to like your organs, when sending that information back to your brain, it can cause inflammation in your brain, which causes like depression or any other like
That's what you talked
brain
about
disorder like that.
before.
And so if you stimulate the vagus nerve, it can help with depression, and it also help with bipolar and temporal lobe epilepsy.
Yes.
Yeah, you should look at it.
Yeah.
Did you talk about inner world and outer world?
Oh, like.
Yes. we
the-
talked about this.
So
Nerves
vagus
and
nerve, just
everything.
think it's the way that your brain knows what's happening from your inner world.
Yes.
Yeah, it's nerves and-
Very good
nerves and-
questions. These are all ones that I also have starred that we were going to talk about, so, yeah, very good.
You talked about the distance relation.
Between the ganglions and the tracts,
Yeah.
or is the tracts and the nerves and the sympathetic and parasympathetic?
Yes,
Okay.
nerves and ganglia, I think.
We talked about Mueller.
Okay.
Or is that later? Have you guys talked about the Mueller-Lyer illusion?
No.
Okay,
Mm.
that's probably tomorrow.
It's on your Quizlet from last.
Yeah,
But-
went over it, but because they have a review session tomorrow, so they won't have to know about it.
Okay, well, okay, never
That
mind.
one's a cool one.
But if they don't need to know.
We won't cover it. If you wanna be like super cool and then like show it off to Bob.
It's just the one where like, if you have,
If you did Gen Psych, you know what this is.
Yeah,
and it's,
And then, yeah.
even though these lines are the same length, they're probably not actually, because it's not a drawing, but imagine that they're the same length, your brain would assume that this one is longer than this one because of like how corners are constructed in houses, and cultures that don't have houses that are built like squares don't have this illusion. They know that these lines are the same length.
Like a teepee, because I had no idea what the hell you were talking about when you said cultures where houses aren't squares, the cubes. I was like, what?
Yeah,
So
or
a
like
teepee.
domes, kind of.
Domes, teepees.
so another good way to think of this, the Mueller-Lyer illusion is when you're thinking of like a box, think of like a cardboard box. You can think of the reason why this illusion is taking place is because of our idea of depth perception.
Mhm.
So when we see these two arrows facing this way, this kind of looks like the top of a box. Like if I were to like draw out the rest of the box here, it would kind of be like, hey, that's the box.
It's far away.
Yes, and this would be like the inner side of the box, so it would look close.
And so we assume that it's larger because they're the same size, but our brain thinks it's farther away. And so its size would increase as it got closer to you.
So it has to do with depth perception, but yes, certain cultures that don't deal with like buildings that have a bunch of skyscrapers and square shaped buildings won't typically see something like that. So it probably won't be on the exam, but it's pretty cool.
Yeah.
So if you want to be like super cool and impress Bob,
Put it for extra credit.
yeah, put it for extra credit, honestly.
This is part of class and you're learning.
Yeah, it's what we learn, so it's what you're learning.
I don't know what's happening. He said, oh, I didn't have enough time to make one. Mary, do you want to make an exam? I said, I do not have time for that. It goes, me neither. And that was their organization, so. I could make the exam. I
That's
probably, okay, here's the thing is I would make them real easy.
Oh.
Which he doesn't really want, but.
Make a 40 question
Just
quiz.
Make a
Here-
40
okay,
question
another
quiz
thing-
based off of that study guide.
In the cohort for this, or, no, okay,
That's what it's.
So,
not to shit on you, but I heard from other students in this class that posting study guides when you're not in the cohort is kind of confusing, because then they have to go through, like, look through all of them. So if you make it for yourself, but don't post it, because if you're in the cohort, post it, but if you're not in the cohort, don't post it.
Yeah, I wasn't going to, and I emailed him it,
Mhm.
and we could make a study guide early off of it, and he said, put it in Canvas.
Okay, well, if he says otherwise, then listen to him, but try to avoid posting if you're not in the cohort, because it confuses people.
just
notes.
You did- That's okay, you're all good. I'll try and figure it out for you, to the best of my ability.
I'll take it in 2 weeks.
Germany.
The family hosts like a foreign exchange student, and so the foreign exchange student was like, hey, you wanna come back with me during spring break, so like, how do you do?
Oh my god.
Yeah.
All I gotta do is house a foreign exchange.
Yeah, just that.
Okay,
Sleep on the couch for a few.
that's true. Any other questions? Now it's just you, Dave.
I think she was eleven. Is anybody allergic to nuts in here? No. Okay, I brought trail mix, but
Also, is this kind of helping? I just kind of want to get a gauge, because most of the time people are like, yeah. But-
Yeah.
Okay, good.
I feel like I'm asking every question ever, but can we talk about the ponds?
Yes.
Yeah.
The ponds? The ponds.
The ponds.
No, remember that.
Something about-
Latin or Greek for, no, is it Latin for bridge?
I don't know.
I don't know.
I have it written down in
Great.
Greek in my notebook, but I think that I just made a mistake. and it's actually Latin.
Like the ponds.
So, okay,
Yes.
the pons is what connects your brain stem to the spinal cord.
Yeah.
So like the brain stem, like when we're drawing this thing, that's like the brain stem, your spinal cord keeps going all the way down. The thing in here is what connects it. Right?
Like, it's kind of like
It's
right up
right
here.
Is it up
here.
there?
So
Yeah.
it's a Latin word that means bridge, which is really useful, because if you can just think of it as a bridge, it's connecting the rest of your brain to the spinal cord. And all of your descending motor axons run through it and cross in there. So that's why if you have damage to it, you can't move, because you can't have motor communication to your muscles.
Yes.
PONS,
Yes.
Descending what?
motor axons.
Yep,
Did you go over gray matter, white matter?
I did.
composition? Oh, okay. I didn't see
You were talking about that when I came.
So, yes, the pons, you can also think that this is the area where your descending axons cross over. So that's why, like, when you have, basically, say you want to move your left side of your body, thanks to the pons, that is what carries this information from the right side of the brain to be able to move that left side of the body, because the information crosses over at the pons. Why?
For motor information.
Yeah.
There, yes, for motor information specifically. So that's why that movement of that side of the body is correlated to the opposite side of the brain. That is contralateral movement.
And you have those up there, right?
I'm gonna take a picture of the board.
I know I'm talking about it, I don't know.
Need be, we also have it all recorded.
Hmm?
Need be, we also have it all recorded.
So basically, if you have like damage to the pawns on your right side, you would have trouble moving things on your left side?
Yes.
Okay.
Typically, if you have damage to your pawn, there's more issues that you would have to worry about, but particularly because it is also involved in kind of the hindbrain, like your medulla, your cerebrum,
Cerebellum.
Cerebellum.
This is,
Cerebral cortex.
this is
or
your
cerebellum?
cerebrum.
cerebellum.
That's your
Yes.
cerebellum.
Your medulla, your cerebellum, and then your pons are all three major factors of the hindbrain. And generally, a lot of that stuff is like base function regulated.
Survival.
Yeah,
The
so,
reptilian brain.
yep. It's what you need to do stuff like respiration or your heart to beat,
Yes.
which is oftentimes controlled by the cerebellum.
Let's talk about the cerebral cortex. I don't have
Yeah.
anything for it, I just have the time that we was talking
So
about it.
the cerebral cortex is just the outer covering of the brain.
Yes.
So not the cerebellum or anything in the hindbrain, but this part up here, the outer covering of that, so like the gyri that are on it, that's your cerebral cortex, and it's the evolutionarily the newest part of your brain.
Oh,
Yes,
yeah.
it's kind of what makes people.
Yes.
The
Or
tri-brain.
Yeah,
Triune.
triune brain.
Triune
That's the
brain.
neomammalian part.
Yes.
I love how I'm also kind of learning all of it again.
I know, everyone remembered different parts of it, and now we're just kind of like, the three of us together were like the power team. So
So the cerebral cortex is the outer part, and then there's like three terms, like the grooves or something, the.
Yeah, so you have the gyri, which are the bumps. I like your finger analogy that you use.
Yeah, so the way I memorized it was, you have your hand, you go like this, make like a curve. Actually, you're gonna have to remind me what the terms are. Your knuckles are like the outer bumps.
Those are the gyri,
Okay, and then the grooves between your fingers are the deep
the sulci.
sulky. What's the other one?
And then so if you have like the big ones that are in your brain are the fissures,
Vision, oh, that's like dividing.
hemispheres.
Yes, okay.
So you can think like your central fissure is basically where that brain splits into,
So like
right?
a fissure is like a really big.
Very
line.
deep, yeah,
goes
from
into the-
Like when you
pronounced.
see the brain,
Oh, is
the
that
two
like
parts that like,
where that, what's that called? Like a corpus?
the corpus callosum is this thing that,
Connect.
So that's
Connects
your,
them.
yeah, that's your lateral fissure, is between the hemispheres.
Lateral.
This is your central fissure, so this is your frontal lobe and your parietal lobe. And then if like you see like your frontal lobe, and then you have the temporal lobe down here, there's a big fissure that runs here, which is called the Sylvian fissure. But I doubt he'll ask about the
he's
Sylvian
not gonna,
fissure.
I don't know that.
Yeah.
If he asks about any of them, he'll just ask about the central fissure, which,
I think
That's the
he
one
doesn't
that-
even ask what they are, he just asks
Oh.
what is a fissure.
yeah,
That's just the
Yeah.
deep grooves that like separates the.
yeah.
Yeah.
I'd kind of start down in your notes, primarily gyri and sulci
Mhm.
or sulci, because I think I remember something like that being on the quiz. So just remembering that gyri are bumps and sulci are like the little grooves. That will be important. I'm 80% sure.
And if we were at the test, then.
Yeah.
There would be nothing.
I
left
would
in-
be down to write the text.
I know.
I feel like I would make it actually understandable.
Bob,
I'm writing the test, Dr. Lloyd. I'm not. I actually, should I ask him to?
I mean.
Do I have
we could-
time?
Let's
Who
do it.
knows? We can write the
we could
text.
collab.
Collaborative TA.
Well, because they're
exam.
only like 16 to 20 questions long. and
Yeah.
We split that among 3 people.
Oh, yeah.
That's not that
Or
bad.
Do it together.
Yeah.
We'll make them the hardest.
Yeah, we're gonna be like.
Yeah, literally.
Spelling counts in this one. What are the 4 parts of the technicum?
Oh my god.
Have you told them?
Okay, this is just a us thing. Do you find the occipital fissure to be annoying because it's like not pronounced at all?
Yes.
And it seems fake.
I don't even notice it.
I literally don't believe it's real.
Have you told them about the 3D brain? website.
Oh, yeah.
Have you told them about that?
What?
The 3D brain.
3D brain facts.
Yeah, the one that we
About
linked on the.
I linked it on the PDF that I.
Yeah.
But I put all of our whiteboard onto a document.
I can send out the announcement after this with this video as well.
Okay, I'll put it into it easier to understand, because my ass was not gonna watch those, you know.
Right.
I'm gonna show you guys a really cool website that you can use to study the anatomy of the certain brain like structures. It is called brainfacts.org. We'll put it in a Canvas post, or it should already be in one of the Canvas
It's
announcements.
in the PDF that I put on the, just last night's announcement.
So if you go to the announcement, there's like a link button you can
Yeah.
press, you click
Yes.
that, and then
Um,
it'll have the link on the PDF that opens.
It is specifically, if you look at like the 3D, there is a 3D version, so if you just search brainfacts.org. And then look for like 3D.
I have it bookmarked on my computer now.
I was gonna say, I just saved it. That's what I've been looking at.
I do not.
Here, I'll show you. You don't figure out. It's like this. And I'm like,
But
no, going all the way.
I'll show you guys, I'll kind of walk around. I'll show you on here kind of what brain facts looks like. So it's a really good structure. It allows you to kind of see parts of the brain, and you can even go and into your selection and select specific parts. It will highlight them and tell you a little bit about what it does or what, you know, needs to be done in that section of the brain. You can also look inside the brain, pretty much pull it apart. It's a really good learning tool. So I'll kind of come around and show you guys.
Mary, you said you guys talked
A little
about
bit about it.
you said you were talking about like the distance between the.
We haven't talked about
You
that.
haven't.
No, I was asking that. I was like,
Yeah.
I showed up, he was already started when I showed up, but
I got here right away, but when I had to. So. I had to-
I was gonna say, I was like, there's an extra computer here and an extra back.
Yeah.
Who's with it?
We can, I don't know how much of that's really going on the test, but it helps to know.
I remember being on the test, and
Was
it
it?
messing me up, because I didn't study it.
It's, yeah, I remember studying it and it being, I'm being like, this is the
Yeah.
hardest thing.
I know.
It
What are
was,
they called?
So. That will be.
it's so you were right, it's the ganglions and the nerves.
Yeah.
The parasympathetic, presynaptic, and postsynaptic, presynaptic nerves, postsynaptic ganglions.
Really, really good.
And then it was the sympathetic,
Mhm.
presynaptic nerves.
Oh, yeah.
The ganglion, and they all communicate with norepinephrine,
It's
except
what
for,
kind of like
I think,
gave me. the ability to
postsynaptic
understand, like where stuff is in the brain.
sympathetic
So,
ganglions use acetylcholine.
You tell him, I
We
wouldn't
have
know.
gone.
I'm gonna have to read through my notes really quick to remember this one.
Let me
Oh,
know.
wait, wait, Perfect.
Internal organs.
But yes,
Sympathetic nerve.
absolutely.
You know what's funny? I'm literally just looking at it, I was like,
It's
What?
really, really.
So that's-
because then you
that's
don't
just-
have to
Yeah, yeah,
sit
yeah.
with notes. So you can just kind of go on there and be like, oh, I want to talk about, you know, I want to talk about like the mesencephalon or like the midbrain, stuff like that. And then you can like specifically focus down, say you want to focus on the tangentum. Then you can be like, oh, the tangentum, it's like four subparts. Well, what do each one of these
Okay.
four subparts do?
Okay.
And you can go individually, piece by piece.
figure out. That's legit, okay. I'm actually gonna-
Look up, look norepinephrine.
Well, I literally just got it. I have work. That's not part of the test.
Okay, yeah.
This one? See, okay, here's the thing is, this is safe from whatever they throw it, you couldn't understand any of.
Oh, there's also the, Word doc that I made.
Oh, I don't know where that is. I don't know the name. I'm just gonna, okay.
Also, for the next exam, I was in the cohort for the next exam, so I have a lot of information on
Got
that.
it.
And also, the next exam will be more like chemical.
Yeah,
Yeah.
it's very like applied bio. The rest of the class is bio.
Don't.
Okay, you all say
Don't
this
worry
was the
too
hardest
much.
test. This was the easiest one for me because I memorize locations, names, definitions very easily. I can't do biochemistry. I can, but,
I have to show you this crazy video I have.
oh, okay.
No, this feels doable.
Biochemistry,
the drop button's
gonna-
I
Yeah,
used to be a biochem
I don't know
major and then I
For the-
dropped
No,
chemistry
for the
and I was
one
like,
hour.
But I made it to
Mine
OChem
really
too,
excited.
so I get this.
He walked down.
So next exam, I
So
got
then-
it.
I took what we can, peak COVID. I
I
don't
have-
Is that chalk?
It's
I know,
fun.
That's.
I had it, it was banana.
Any
He walked inside his space, I mean,
particular
she's
questions
like,
that people have so
person.
far?
It's-
It's actually.
It's literally
this might
above my
be
phone.
silly.
It's.
Oh, yeah,
everything.
have you seen the
Sometimes
standing
priests
a little
go into
more?
houses and they.
Yeah.
That's what that looks like. That's what it's.
Absolutely.
Yeah.
Yes.
Okay,
That's actually.
I don't know where to put this now.
I think, okay, I have pictures. We can just erase.
Yeah.
That's what I'm thinking. I can erase it.
Do you have a recent one?
This is how I studied this is how I studied for unit 4.
I know you showed it, that you wrote it on your wall.
I had it written on all of my walls.
Okay.
I did post-it notes and I put them on my
Well,
wall, but my
uh,
entire.
We're gonna
wall-
wipe the board as of right now.
I have a picture.
We'll upload a picture for those of you who are just arriving. If you are confused about anything that we previously covered, send me an email, I'll go over it.
Don't, okay, don't email me. I probably won't respond. I'm gonna be very honest with you. I also don't know how to answer a lot of questions, so email him or him. They actually know what's.
I'm mostly like a majority of the time.
So I would just repeat it until I had it.
So, a particular question about ascending and descending pathways.
Dorsal and ventral pathways for. Did you guys know we did the where and what?
I do right now.
No, we figured that's where you.
That's the next unit, yeah. What I would talk about as for ascending and descending pathways, concurs with
I'm sorry.
afferent and efferent, information. You write it down because I hate spelling and I hate drawing, so.
Here's your spinal cord.
So perfect. A good way to remember the difference between afferent and efferent information. Afferent starts with A, the first letter of the alphabet. So it's the first letter, so you can think it's the first thing that happens in communication. So oftentimes afferent is affectionate. It's what you feel. It's the sensations. So it carries information up to the brain. And that is oftentimes correlated with your ascending tracks inside your tracks. Maybe. What's the other word?
Nerves.
Nerves. Thank you. It's your ascending nerves kind of throughout the body. So your nerves pick up senses from what you feel, what you see. Well, that's a different pathway, but everything else, pretty much what you feel. Is your
Somatosensory.
somatosensory, yes.
So the feeling on your body, basically.
And that goes up your spinal cord to your brain. It gets processed. There's more in-depth stuff. If you want, we can go over that. But I think the general idea is we just want to know that senses and what we're feeling, the affectionate, the afferent, senses are going up to the brain to be processed. Efferent is your effect. You're effecting something. That is descending. So that is all of our sensations have come up, been processed, and now we are acting on it. We are moving, we're effecting the environment around us.
The outer world.
Yes.
Never remember which one's the dorsal path, which one's the ventral.
Um,
Or like with the specific neurons in the spinal cord.
I don't think that will be on this exam, but I guess if you take anatomy, it is important to know like, oh, which one's in the front, which one's in the back. I can't remember off the top of my head, even though I take an anatomy. Shows you how well I did in anatomy. But let me double check here.
Oh, I'm in contest. I don't know.
I'll double check here quick and then we'll figure it out. Because I believe that,
I have it in the
This.
cognitive subject. Yeah. Dorsal is incoming.
yeah,
That's what you're.
What direction? Incoming, okay.
that sounds correct.
They would both sound correct to me.
Ooh, we should, I have a proposal.
Proprioception.
Proprioception, that word.
How do you spell that? I have it in my notes, but it's all messed
Proprioception. We will.
You right now.
I think that's
Yeah.
Okay.
PREO.
This is an I. Perfect.
Isn't that the one where like your body,
That's the ability to know where your limbs are in space without seeing
and
them.
the only thing that can is your eyes, like that's.
Yes, because your eyes don't send back some amount of sensory information.
Should tell them the story about like how, when you were at the party.
Oh, yeah. So we learned this, and then over fall break, I drove down to Madison to visit my friends who went there. And so if you drink a lot of alcohol, they inhibit your somatosensory neurons.
Oh, is that
Going-
when you like stumble and like fall over?
Yeah, so that's why you stumble,
Or
fall
brain
over if you drink, because it inhibits the sensory information going up into your brain. And so because your brain doesn't have the sensory information, it doesn't know where your limbs are and you lose proprioception. So when you're really drunk, you don't have any proprioception. So when I was visiting my friends in Madison on Halloween, every so often I would close my eyes and do this just to be sure I still had my proprioception.
Wow.
And my friends were like, "What are you doing?" I was like, "Well, try."
That's, oh, I didn't know that.
That's another way when they do like the sobriety test.
Yeah.
And they like tell you to touch your fingertips to your nose.
Or walk in a straight line without looking at your feet.
Yes,
Can't even. He's like, how's it going? I'm like, I don't know.
so, yeah,
Yeah, I'll write it on the board.
you're gonna be the designated writer.
If the dorsal roots in the spine activate, die. According to this.
Ah, yes, so if your dorsal roots in your spine die, you lose proprioception.
Yes,
Like
that's,
sending and descending and now.
A good, like,
We were talking about being drunk.
yeah,
And when,
yes,
when you get,
hypothetically, if you were to drink too much alcohol and you fall over,
which we would never do.
it's because your body doesn't know where your limbs are in space.
I was walking to a guy's house and I saw a guy from which went and just fell over on a stack of chairs in the street. I was like, someone doesn't have their proprioception.
so, another fun, like, weird body error that occurs because of proprioception is also kind of the ideals of like a phantom limb. So like, say you had like your hand severed. Some people who have that, oftentimes like report feelings of, oh, I can feel my hand. That's kind of because of proprioception, but just the lack of the hand there. So it is a body error. There's a few different interesting facts about that, but it is
It also has
also
to do with
related in
neuroplasticity in the somatosensory cortex.
yes. Basically, in layman's terms,
So if these
Your
ones
sense.
die, then you lose proprioception. Yeah, then you won't have proprioception because your legs can't, or your brain doesn't like feel where your hands are and where your, yeah, there's no communication between your arm and your brain, or your leg and your brain, or any of your organs.
awesome. Any more
And
questions?
then, yeah, it gives you a really good litmus test to see if you're too inebriated or not. I never missed.
As soon as you start getting older, everything just sucks. You talk like you're 50. I feel like I'm 50.
Aren't you 22?
I'm 22.
Old.
See. Such a geezer. It gets to a point where you're like, I can't have more than 2 drinks, otherwise it's all over. And then, yeah, aches and pains, that's how it goes now.
If you're young and spry.
Yeah.
Like me,
Actually, I don't think you can.
It's like, I remember.
I'm gonna make it up with like a walk. Just.
Probably too. It takes me like an hour just to get out of bed, man.
What if you tell me that, like, I have to stop drinking because my veins will like explode or something?
Yeah, like. What were we talking about?
I don't quite
You
remember.
were telling a story. You know what I'm saying?
Yes, I had a massive dissection of my.
Oh, yes, well, good, shortcut.
Yeah, so, I was involved in a car crash that nearly killed me, and,
Oh, did I have a shortcut next season?
yeah, so basically, think of like a bag of meat.
Mhm.
Have a good time.
Oh.
That's what happened. Details that I can share later.
I don't know if I need to.
Well, you're alive.
Any more questions?
About purpose.
Questions?
Are we, is everyone ready to move on? Okay,
Yes.
I have a question about the telencephalon mesen.
Oh, yes.
What, and then I just have hindbrain, is there a term for that one, or?
Yes, but he won't make you know it.
Okay,
Yeah.
Yeah,
no,
because he doesn't like the terms for it. He's like, I've never found these helpful. Cause it's like the
He hates a lot of things.
mesencephalon and like it's those ones.
And
He just
nice
likes
middle.
Yeah. MESEN, cephalon.
cause it says there's like things in these areas we talk about, like,
Yes.
that's like the tectum and the superior, yeah.
Yeah, so we'll go into that
Tag
in a little bit more detail.
G, I mean,
Wait, the one and the.
these are part of the
What's the?
telencephalon. That's sorry, yes. I think that's-
No.
I know. In tangentum, but, and I know some of what's in the tangentum, but you might be.
I know, yeah, I got them. I got
Okay.
them in the noggin.
So, the first two things that are inside, the mesencephalon are the tectum. We'll write that out, and the tangentum.
Did I spell that right?
Yeah, I've seen it spelled both ways. Tegmentum and.
I don't know. I'm so bad at spelling, but I mean, like, also again.
We don't grade on spelling anyway.
Yes, we'll keep referring that over and over.
Did I do it right?
That's right.
Okay.
Tegmentum. Tectum and tegmentum. The tegmentum has a few more parts.
Oh, I'll write them up here right now.
The tegmentum has a few parts that are possibly important to know. Personally, I don't remember them being on the exams, but they do, so I will trust them on that. They basically have a lot of, I'll cover as much as I know, and then he'll probably pick up from what I left off. I remember the three ideals. There is the red nucleus after
Wait, and that's in the what?
tegmentum inside the mesencephalon. So there is like three sections. There's the mesencephalon, which contains the tectum and the tegmentum. And inside the tegmentum, there is 4 nucleuses. There is the red nucleus, which pretty much has to do with, I believe it's pathways. It sends information,
Your,
correct?
for the red nucleus?
Yeah.
Your motor axons.
Motor, okay, so it's descending. The red nucleus has to do with your descending information. So that is coming from, I believe, motor path, your primary,
Primary and associate motor cortex.
yes, primary motor cortex and
Vitamins
associate.
4 and 6.
And that will basically come down the red nucleus and eventually go down out to the rest of your body in order to move.
Yeah, all you need to know is that motor axons go through it.
Yep. The substantia nigra, it is a very important part. This is probably, I guess, the most important
Yes.
one to remember.
100%.
The way to remember this is it is like a very dopaminergic area, or it's very dopamine centric. It has a lot of areas that produce dopamine, and that is why it has a dark color, is because melanin is a byproduct of dopamine.
Yeah.
So, yeah.
Which one was this one?
Substantia nigra. A way you can kind of remember that is, nigra in different languages means,
It means
like
black in
black
Latin.
or dark in color. So that is kind of the way to remember it and correlate that with melanin, and correlate melanin with dopamine production. So that's inside the tegmentum as well. You probably understand the other two a little
Yeah,
more.
so the periaqueductal gray matter, it is involved in transmitting pain sensation into consciousness. And then the rostral end of your reticular formation is also part of it. So the reticular formation is a long beam that kind of goes from your brainstem all the way up into your mesencephalon and ends right at the thalamus and the diencephalon. So you can see the mes is right here. The diencephalon kind of surrounds it. And so like right at the edge here is where the rostral end of the reticular formation is. Rostral just meaning head, basically. And this is very involved in attention and specifically for the rostral end, wakefulness.
Can you
And-
go over the gray matter one?
Yeah, it transmit pain sensations into consciousness.
Yes.
And you said that tegmentum was in the mesencephalon?
Yes.
So a good way to remember these, mesencephalon often correlates to stuff in the midbrain.
Mhm.
So all of that stuff, you can kind of think of, like emotionality. A lot of like areas that have to do with dopamine production.
Mhm.
Later in the units, he'll talk more about like Parkinson's.
Chapter or test 6 is all about dopamine and
Yes.
schizophrenia and Parkinson's.
So
Parkinson's.
it's,
And
I'd
so-
say that like knowing the substantia nigra is probably the most important one.
Yes.
But I know like maybe 1, 2, if not all of them, just because he might be like, hey, what are 2 of blah, 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 that I think I might have remembered.
Yeah, so know them for this test is good. You will never talk about these 2 again. Unless you ask a question that relates to them. You're gonna talk about this one a ton, and the reticular formation gets brought up a little bit when he talks about attention and autism and ADHD.
Yes.
Yep.
I was wondering, the substantia nigra. You talk about like dying out dopamines.
Yeah, so this basically is what sustains your entire midbrain with dopamine. And so the things in there like your nucleus accumbens and your basal ganglia, which need dopamine to function, get it all from here. So if this starts to like decrease in size or die out or anything like that, I guess those things are the same. Then not enough dopamine gets to there, so you can become like depressed because you don't have enough dopamine going to the reward center, which is the nucleus accumbens. Or you develop Parkinson's because the basal ganglia is what controls voluntary ramp movements. And so you kind of like get like the palsy associated with it and you can't control your limbs as fluidly because it doesn't have enough dopamine.
Yes.
Did you go over
One of
how?
the things that we did right, for the ramp movements and
Yeah, I have not done that yet, but basically, do you want to explain that? more?
The ramp versus ballistic?
Yes.
Okay, so you voluntary ramp-like movements are just like, I have this pen in my hand and just like bringing it to wherever when I set it down, or just like these things that we're kind of more conscious of. A ballistic movement is a reflexive movement. It's in your cerebellum, so you can think of like reptilian brain, and it's like if you threw a brick at somebody and like quickly dodged it, that's a reflective movement. It's subconscious, and people with Parkinson's have no trouble moving in that regard. It's just these voluntary movements, voluntary ramp-like movements that they struggle with.
Yeah, and it will be all like kind of jolty.
Yeah,
By the
if,
tremor.
Yes, you'll see Parkinson's patients tremor. So there's a lot of things that have to do with the substantia nigra. You can also think that like if some areas that like require dopamine, this is producing too much dopamine. You can also get examples of schizophrenia in patients.
do not say that schizophrenics have too much dopamine. He'll lose his
He
mind.
will punch you. Not actually.
Schizophrenics are highly sensitive to dopamine. I said that one time to him, and he's like, no, no, I was like, sorry, I'm so sorry.
Because you can never have too much dopamine. But yes, if it is producing like a higher amount of dopamine that isn't, being able to get cleared up by other I guess enzymes that break down dopamine, then it lingers in the body, and that means that your receptors are picking it up more often. So that can lead to schizophrenia and kind of the reverse with Parkinson's. If it's not making enough, then there's nothing for the receptors to get access to.
So you're saying, okay, so you're saying the substantia nigra, it sustains entire just brain or dopamine?
Yeah.
How would you do that?
I would say that the substantia nigra produces.
I think it's just the neocortex.
Other areas.
Because it looks like on that photo,
basal ganglia.
it has the pride on it.
Other areas, I
Yeah.
don't know off the top of my head, but that was the main one that I was.
Yeah, I mean,
basal
so like,
ganglia.
there's the dynamic one, there's the
Does
dynamic one,
that.
and then there's all the
Grand
types of ones,
movement.
frontal,
And-
parietal, temporal, occipital, just the whole neocortex.
Oh.
And like some there's like superficial and subcortical.
Yeah, I assume, I don't know how it's spelled,
What?
basal ganglia.
BASAL.
Where am I gonna find that?
You know what ganglia?
No.
GAN.
And.
Ganglia?
Oh.
GLIA.
Yeah.
There we go.
You did it. I never thought that there was an N in there. I did not hear gang.
That's
Ga-
voluntary.
ganglia.
That is that voluntary branch like movement.
Yes.
And for the stuff we just talked about, do you think that he'll ask us to like name the tegmentum,
Yes.
diencephalon? Do
You
you
did.
think, I know, but do you think he'll also ask us to explain the things that you guys underlined, like under it?
Possibly.
I do remember him asking, again, the test might be different, but you should know that the diencephalon connects the mesencephalon and the telencephalon,
Mhm.
and what the main parts of it are.
Yes.
At least a main overview of what it is within it. You don't have to know necessarily like what each individual section does. But I
Yeah.
would know the substantia nigra.
Yeah.
That's most important. But if you just know a general overview, that should be good.
Don't worry about anything in the tectum.
Yeah.
That won't be important.
Yeah,
Honestly, we should talk about the thalamus and hypothalamus though.
yes.
For the telencephalon, just know it exists.
Yep.
And that what did you say?
It's the neocortex.
The neocortex, so it kind of has,
And then some like, I was gonna say superficial
they don't. even-
subcortical tissue. It's like the collegiate cortex as well,
Yes.
but don't worry about that.
Cortex.
So if we say something, the diencephalon connects the mesencephalon and the telencephalon, and like diencephalon has the thalamus and hypothalamus, and like you talked about the substantia nigra as well as like the reticular formation.
Mhm.
Do you think that's like good?
That would be like an above,
That
that would be
doesn't-
like you hit all the,
I would say. Just know the overview
Yeah.
of
Yeah.
that it connects them. The substantia nigra exists and where it's part of.
yeah, so there might be like two separate questions where it might be like,
Yeah.
what does the substantia nigra do?
I
And then.
would know what's in the tegmentum.
Yeah, that's the other thing that I would say is just kind of like, know what's inside these things. And then know what the substantia nigra does, or like know what this, like, I would say that most of the red nucleus and gray matter, you probably don't have to know.
It doesn't hurt to study them, but because it's like extra credit, but I would be shocked if they were on your test.
You should talk about the thalamus and hypothalamus.
Yes, those are important. They'll have to know that for
I'm
sure.
gonna just erase this and then.
Yeah. Is everyone good with this so far?
Wait,
Okay.
let me take my shot.
Yes. Awesome.
So the thalamus, which is in the
Diencephalon.
diencephalon, contains the nuclei, which are, those are bundles of
Somas,
soma.
cell bodies.
Cell body, okay, so contains the cell bodies that receive sensory information and put it into the right parts of your brain. So the thalamus and the hypothalamus kind of. don't know how to explain that. I'm gonna say they kind of, show.
I always get the two mixed up
Yeah.
when I try to think about it, so.
And the hypothalamus sends information to the pituitary gland and other.
If you just know that the hypothalamus tells the pituitary gland what to do, that's probably good enough.
And it's like involved in hormonal communication.
Yeah,
Just put the word endocrine and I'll give you full points.
honestly, very valid. It is involved, so you can think of endocrine as like your blood system. It's basically what circulates through your body. So in a way of the hypothalamus, what it does is it talks to the pituitary gland. And it says, hey, you've got to make some hormones for the body. And we know that hormones basically circulate through our blood system to provide, I guess, like, I don't want to say nutrition, that's not nutrition, but like information. It's like a certain regulator. Hormones are kind of like neurotransmitters in that way, where it's like, hey, if you are accessing so much of this hormone, your body is going to act differently. So that's where it's like, people often kind of correlate like the hypothalamus to like arousal in that kind of sense, where it's like it produces your sex hormones and stuff like that. And those circulate through your blood, so it's involved in endocrine pathways, which is really important because like endocrine is so cool, and that is my specialty. The thalamus, I don't know, they can explain.
I will say, so it helped me remember where, so the thalamus and underneath is the hypothalamus, because hypo literally just means beneath. They're on top of each other and they. What am I trying to say?
Communicate with each other.
Low.
Beneath, lower.
Oh.
You know, under.
Yeah,
Under,
Lower.
though. Cool. Any other questions about thalamus, hypothalamus? Or want us to like restate in a not so crazy man?
I don't know the question,
Yeah.
just more so like, we could give like an explanation. So today he mentioned something about how like, people with PTSD, their heart beats like more regularly than like irregular, because like, you remember what I'm talking about? Like their amygdala says to the hypothalamus that it has, that like it's taking like an intense like, the amygdala, so then hypothalamus, and then like the hypothalamus then makes like the heart do something.
So the amygdala is involved in emotion primarily, so it's pretty much what makes you feel things.
Specific or principally fear.
Yes, so basically what PTSD patients have is their amygdala might react very heavily towards something that they perceive or sense. And that will talk to the hypothalamus, which is like, yo, pituitary gland, you need to make a bunch of hormone X or whatever hormone. And that is something that can seriously pump up the heart. For example, like epinephrine is an example of that, right?
Yeah.
Hormone.
Yeah.
That would be actually probably the hormone that makes the heart pump a lot faster. Is you're like,
A more common name for epinephrine as well is just adrenaline.
oh yeah.
So in the States, we usually call it epinephrine. If you go over to England, you'll hear it more as adrenaline or noradrenaline, if you're talking about norepinephrine. So if that makes a connection in your brain,
If you say adrenaline.
we'll get it.
I won't. No, I'm kidding.
How's that you?
Cool. Did that explain?
You did.
Cool.
I don't think he told us about that, but you know enough about the endocrine system. I was
Well,
like, he's
the
got it.
amygdala.
Yeah.
I love it.
We even
We're
know
gonna-
it's not on the thumbs. I just saw the added, except
I just put that there in case he asks some question about like what makes smell or olfaction different than other senses, and it doesn't go through the thalamus, it just, the nerves in your nose go straight to the primary olfactory cortex, rather than going through the thalamus and then to the cortex. So if he asks about that, I just put that there, otherwise it won't be that important.
And I mean, you can always put that down for extra credit as well.
Yeah.
Oh, we
That's-
told the group yesterday, don't put an entire essay worth of information for that extra credit. You really only need 3 detailed points,
Mhm.
6 semi-detailed points. Put whatever you remember down. I don't need everything. I'm not gonna read all of it, to be honest with you. Yeah. So- If-
We probably got
if
to
I
the first
glance,
day.
I'm like,
That's
this
what I
is
feel
correct. Yeah.
Also, pictures work really well.
Oh,
If
yeah,
you just draw a
drawing.
picture and I can point to 3 things that are true on that
Yeah.
picture, it's 6 points.
I love pictures.
Yeah.
Or graphs, yeah.
That makes my life so much easier.
But like, okay, pictures that
Makes sense.
make, and like.
Yes.
That are
Are
correct
part
answers.
of the question.
Give words with it.
Yeah.
If you like drew this and
Honestly-
then just said that like this connects these two,
Yeah. That's,
honestly,
that's a couple points.
that's, yeah.
That's 3 or
It's not
4
gonna
points.
be worth any points, but if you want, you can draw stuff. That isn't related,
agree.
as long as you finish the exam and like, you're good. I don't know, if you wanna draw, you can, probably won't be worth points unless it's related to the content.
I mean,
but
I
Here's what's-
might draw something next to it, I don't know.
Finish up the exam.
Yes, that's the spinal cord
And right.
or column.
Man,
I'll just-
it's not
I'll
like
put it-
you guys are way
Yeah.
up for extra credit.
He did?
Yeah,
He literally
It's like, you gotta you gotta read the book, find stuff I never talked about.
No.
Yeah.
Oh my God, no, just memorize a lot of stuff and hope he doesn't ask it on the test.
Yeah,
was me last time.
I
Like,
never
if
read the
you-
book for this class.
Oh, no, I didn't use the book and I paid $400.
Yeah.
I got the free trial to do the chapter 11 quiz and I never did the chapter 11 quiz anyway.
I can't say that loud, never mind.
I
Yeah.
did spend a lot on the textbook for this class.
Honestly, if
for
you,
cognitive.
okay, I also told this to the group yesterday, if he asks a question about, say, like. The 3 parts, what connects the telencephalon to the mesencephalon, and that's it, and you know more, don't put it in the answer, put it in the extra credit. If he's only asking what connects it, just put diencephalon, you'll get the full points. If you can say the diencephalon, which consists of the thalamus, hypothalamus, and all these things, put it in the extra credit.
Yeah.
it'll also save you a lot of time in your hand hurting.
Yeah.
Yes,
you
my hand
don't
was like
need to-
cramping afterwards.
You don't need a super detailed answer. If he asks one thing and you can just name the word of it, just put the word. You'll get the
Yeah,
points.
That's how I did
Like,
them so fast. 'Cause
You
all
don't
my
need to put
answers
an
were so
essay.
short.
You do it in like 10 minutes.
There was one time he walked in, he went,
Yeah,
Oh, you
like you
didn't
can also put
finish.
down
I was like, I
information
just
about
went,
like what it does. It doesn't hurt, just because sometimes he does expect a little more, but I honestly just put down however much information you think is correct. You don't need to write an essay for every question.
Please don't put an essay.
Because
I don't
I
want to
did.
read it.
And that was-
I really don't want to read this.
what else? What else? I'm trying to think. Last day, yesterday. Last day. Oops.
Did the review session help last time before?
Yeah.
Good.
Cool.
Have you talked about the Olympics and stuff?
I have not, but
Should we?
The what?
Olympics.
Yeah, I think that's useful. I don't remember him ever asking
I
me
think
to
it's
tell
useful,
everybody.
but I don't know if it was on this. Did you talk about the Olympics system?
He mentioned it, like briefly, it's like. Limbic system's like the paleo mammalian brain, right, with like
Yeah.
emotions and
Yeah.
stuff.
Yes.
No, basic.
He just went over
Did
it.
you say what comprised
You
it?
should put that stuff out.
No, I feel like he said he'd go over it.
You
but-
said it was comprised of
Tomorrow, review that.
hippocampus, amygdala, and mammillary.
That's
Yeah.
correct.
Yep.
That's.
Would it be helpful to look at like the slides that he's been using in class?
Yeah.
Word up.
Look for the underlined or things that are in different colors. I honestly, as soon as he started using slides, I was like, oh, this is entirely different. He
Yeah.
wasn't using slides the entire other time. And then like, I just looked at the slides and I was like, oh, it's literally underlined. It's hard to do it in class, so like do it outside of class,
Yeah.
just like open it up and then rewrite your notes and be like, oh, this is underlined, I'm gonna write this down and what it does. That's really good.
Also, if you're, I recommend rewatching the lectures.
Yes.
If he says in class, write this down, write it down, it's probably gonna be on the test. If he's drawing something on the board, it's gonna be on the test. If he's spending multiple days on a topic, it's gonna be on the test. Like, he spent 4 days straight on a, what was it last semester? He was like, do you need me to review this again? We were like, yes. There was something, it was some chart, I don't even remember.
Oh, was it the one, it was one with like haloperidol. It
Yes.
was like talking
Yeah.
about the effect of different neuroleptics.
If
You'll get
he
there.
asks, do you need me to review this, and you say yes, and he reviews it enough, he'll put it on the test. If he's drawing something, he'll put it on the test.
Petition for him to move his laptop.
You can also ask him, say, Dr. Lloyd, I can't see.
We wanna get him a mini microphone to hook up to his computer. Like,
Yeah.
there's audio.
We should get him like a lapel
You can
mic.
also,
Yeah. Reading on the screen. what he said.
you can also
But then
ask
it's like-
him to
like
speak
that.
up, and he will.
Yeah.
Just say like, hey, I can't see unless you tilt your thing up, I'll move it. It's like, can you speak up, and he will.
No,
you don't shit about it. He'll speak up for a few minutes.
Yeah.
And then he'll.
Okay, okay.
Oh, ask him to repeat things.
Yes.
If you don't hear something and you say, can you say that again? He'll say it as many times as you need. Again, he'll probably give you shit for it, but he'll do it.
Yeah. He's like, oh, any questions? And you're like, can you repeat that? Any questions?
Yeah.
That's really fun.
Yeah.
Do you think we're gonna, I don't know if this is on this, this was on my notes, but the calcium induced nuclear. Was that like day one?
Yeah.
Okay.
Yeah, that was, last year?
On the
I
last.
think it's the last test.
What he does is he says that calcium causes action or neurotransmitter release on the last test, and then this test is when he explains how specifically.
Oh my god.
Okay.
So you have the two pathways.
What day was that?
That's probably like day one.
Yeah.
I remember studying for this one, and I was like, we gotta do the calcium. Do you wanna take a photo of this before we erase it? Cause we're gonna need a lot of room. I have it in the beginning of that notebook.
No, literally, this, I was drawing it today.
I was like, they definitely. talked.
See, because I wrote this down in my exam 3 section of my notebook, and I was like,
It's,
I covered this
So
earlier in
luckily,
the
it's like
test too.
really similar to metabotropic synapses, at least the ones with cyclic AMP. Not the
Calcium
ones with the lots of
calmodium
synapses.
protein, calcium calmodium protein. Homodulin.
Yeah, I've been giving him crap around pronunciation.
okay.
Synapsin. Oh, yes,
Yeah.
you'll be an expert at this, because I covered this already.
Oh my god, yeah.
Heck yeah. Oh, first and second pathways.
I didn't
Yeah,
cover
yep.
calmodulin. I can't just say
Calmodulin, I
it.
think
No.
calmodulin.
Yeah.
But all you have to know is that there's a protein and a protein kinase. And that basically stimulates the actin, which releases the vesicles. And then the vesicles fuse with the bouton and then release neurotransmitter out. I'll go over that many more times. I'll rephrase it because this is kind of like just it's what we call in physiology, like a pathway. Very important, because I haven't found a really good way to study them other than just memorizing them. They suck. But luckily this one's only like too long. The next one is a little longer, but
No, this is the long one, and then the other one is like literally calcium to like a phosphokinase, and then it just is done. Oh, no, never mind. You were right.
yes, calcium
Homodulin protein kinase.
modulin protein kinase, then phosphorylates, stimulates synapsin. For those of you, synapsin is basically made of, or there's two things, there's actin and then there's synapsin. Actin acts as the, I guess you could say, skeletal structure of the bouton. It basically kind of like supports, it's a structure, it holds things together. And synapsin holds these vesicles in place. So basically, when an action potential is propagating down the axon and reaches the bouton, eventually it will reach the end of the bouton, in which case it stimulates ion-dependent receptor channels, and that will bring calcium into the cell. Calcium then basically works with synapsin to release those vesicles. Vesicles contain neurotransmitters inside a synapse. But as soon as calcium comes in, synapsin basically is like, let's go. And it's like, okay, now the vesicle can go do this thing. So then the vesicle will then move towards that edge of the bouton. And I believe last exam, an omega structure forms.
Yeah.
And that's where neurotransmitters are released. But specifically what you need to know is the actions of, why does calcium coming in release these vesicles? It is because of how modulin. I hate the way that sounds. It just calcium.
Yeah.
Yeah.
That's because calcium is a larger and more positive element. If you take chemistry, it's because the more right and up you go, the more electronegative. So calcium is kind of like in the middle on the left side, so it's more left.
It has
down.
2 more protons than it has electrons, and
So
protons are
it's-
positively charged, and electrons are electric.
It's a little more
Think
positive than the other.
You don't need to know that for the.
No,
Yeah.
don't worry about that.
No, I just like flexing my chemistry.
You know that divalent means it has
Hmm.
2 charges.
Just 2 charges. You need to-
2, yeah, just 2 charges, I think.
I wouldn't know.
Because you can have a divalent cation and a divalent anion.
Yeah. I mean, I don't think that'll be on the test.
That's gonna be on the test.
No.
Oh, I'm gonna
I'm like taking chemistry.
I've never taken chemistry.
Why? So, did you do all this from your brain?
Yeah. Oh, well,
That's what I'm. really
kind of.
right.
Yeah, you can.
I don't remember any of this. I'm gonna be very honest with you. I don't remember any of this.
Once you like work with it, like if you take cognition, if you take like other classes, they literally just build either under this or above this, and basically you just relate the topics back. So like if you're understanding bits and pieces, good, because like the next time you take this, like a course related, say you want to take cognitive neuro, it's what me and him are taking right now. Literally it is so easy because all of this is just the same stuff.
Take this class.
Do you like cognitive?
I love neuroscience.
It's
Yeah.
really cool.
It's really fun. Gilbertson's a really good professor, and she teaches the class like about cognitive psychology and or neuroscience. And I don't know, she treats you like an adult. It's very
That's
nice.
why I like Dr. Lloyd, because he kind of
Mhm.
teaches you as if you know this, but then.
But also, like, if you have questions, she's like more than happy to answer them.
Yeah,
She assumes you know, but doesn't hold it against you.
that's where it's like, even if you're like not understanding the key concepts, just being able to like see it so that the next time you see it, you're like, oh, I remember talking about this.
Yeah.
Most of the stuff you'll start to see over and over and over again, the more you do psychology, which is why I like psychology. It's really cool.
You guys talk about the calcium ion pump?
That was last.
That was last, okay. Then they won't be on this one. And if there ever is a question that's on this test, that's from last test, you can call them out and get extra credit. That happened to us and we got 4 free points.
You got 4 free points.
Other people probably
I
got
got
4 free
4 free
points.
points.
See,
I got
You
it right.
got 4 free points. I didn't.
But you also didn't lose any points.
That's true.
Perfect. Did you want to cover the bottom one? I don't.
Yeah.
Know that one as much.
So calcium will go in, and that calcium, if it doesn't complex with calmodulin, will just activate calcium dependent, they're supposed to say dependent there, calcium dependent adenylyl cyclase, which should sound familiar from metabotropic synapses from last unit. Those just turn the ATP, which is in the bouton, into cyclic AMP. And then that cyclic AMP activates another enzyme, which is called cyclic AMP dependent protein kinase. We can see a protein kinase up here. It just stimulates the synapsin to break off from the actin so that the vesicles can form omega structures.
If you guys are ever having trouble, like with like, what does this do? What is this enzyme? You know that enzymes end in ACE. And a way to remember, you know, what an enzyme is going to do is, you can think the way I like to describe it, and the way that sticks in my head is it's kind of like kind. They are kind of like promoting something. They're promoting something to happen, so they're being nice and they are being kind, so they're promoting something. If it does not have kind in front of it, normally it's breaking it apart. Trans means to like transfer. So
This will all be taught to you next unit as well.
yeah, so kind of this is like at the point where I was like, I don't know what any of these enzymes do. The best way is just to like think kinase, kind, transfers.
Yeah,
And if it doesn't say it, normally it's breaking it down.
yeah, so it's just an enzyme that moves a protein and needs cyclic AMP.
Read it in
Yeah.
reverse.
So do we have to know, like, when we were talking about CMP dependent protein kinase, he said it was dormant. Do we have to know something is dormant or active?
Yes.
Okay, what's the difference? Because I thought I had it in class and I was completely wrong. 'Cause I
So-
have calcium commodulin dependent protein kinase is active.
No, so it's normally dormant, which means it's not doing anything.
Okay,
So it's like asleep. And then this comes in and it basically binds with this, which wakes it up and causes it to do what it says.
so when it's stimulated, it's active.
Yes, so all of these are normally dormant. All of these enzymes are normally dormant until they're stimulated and woken up.
Phosphodiesterase.
I don't think that you know this one. That was last year.
That was last one.
Stimulates.
Yeah, so a calcium calmodulin complex stimulates this enzyme.
Okay.
Sorry, this should also say dependent here.
I know this is also like a lot. Understandable if you
Yeah.
are like, and my brain is full, feel free to like take a few minutes, go get a drink of water, come back. Or if you're like, dang, I completely do not even remember what the tegmentum does. Send me an email. I mean,
Yeah.
Send them an email.
We love talking about neuroscience.
Set up a Zoom or just hang out with me up here.
I posted a PDF of the review session yesterday, and I'm gonna do the same thing today, basically taking all of what we put on the board onto a document. We're gonna post this.
Mhm.
So, and I will post pictures of our boards, so it'll all be up there.
Yes. If you rewatch this, use her photos because all the text on here is backwards.
Yeah.
It's mirrored, so unless you're really good at reading mirrored things, just use the photos.
So what would be like a question, let's say like a question for the exam comes up, what would be an example of it? And how
It would-
Yeah.
Probably just say, it would name one of these enzymes and then asks what it does.
Like, what does CAMP do within the Bhutan? And then you would answer, activates a normally dormant enzyme called cyclic AMP dependent protein.
Okay. And all. Like the calmodulin, like all, everything's an enzyme.
Anything that ends in ACE is an enzyme.
Thanks.
I
Yep.
was so pissed in the last test because I could not remember the word enzyme for ACE. Like I had it underlined, I was like, I literally just can't think of the word. It was so weird.
I had one person say functional protein, and I count that as well, because it's technically true that all enzymes are functional proteins. So, if you can't remember enzyme, but you can remember functional protein, there you go.
I think I even asked him a question. I was like, just a protein, but I mean like,
Oh, yeah, that's true.
kinda.
Wait, sorry, what would
Go
you
ahead.
call a calmodulin complex? Is it just a complex or what?
Yeah,
Yeah,
just
Okay.
complex.
basically,
Calcium calmodulin complex is the whole name.
yeah, you can just kind of think of it like as like another protein
Yeah,
that is kind of like a binder. So, yeah, when calcium comes in, it basically activates and kind of like creates a calmodulin complex. And then that calmodulin complex binds with calcium calmodulin protein kinase, and then that releases synapsin, which vesicles.
Homodulin is a protein, right?
And that's just when it goes.
Yeah.
Yes.
goes onto the glutamine.
Say again?
I guess you have two areas, because it says like calcium goes into the glutathione, and then there's like, where that goes out, calcium's only
Oh,
into the glutathione.
Sorry, so when you have an action potential, it opens up the voltage dependent ion channels, and then the calcium will go in. And then, so yeah, this is kind of confusing. These arrows coming out are just the pathways
Oh, okay.
that result, I guess, basically from this.
Yeah,
From
so
calcium going.
mhm,
Yeah.
calcium goes in, and then inside it activates calcium calmodulin
Okay.
complexes, which then bind to the kinases, and then that stimulates synapsin.
It's like,
That
in the,
activates the cycle.
Calcium calmodulin kinase stimulates synapsin, which basically those synapsin holds vesicles in place.
yeah,
And vesicles contain neurotransmitters. So when actin or when synapsin is stimulated, vesicles are free to move around, and that is what's sending out neurotransmitters that are communicating in between synapses. Thinking of adenyl cyclase is more this other like second pathway of calcium dependent adenyl cyclase, which that basically turns ATP into CAM.
Okay.
So there's two different paths that it could take. Typically, the top path is what would be normally occurring. But if that isn't the case, then the bottom half is, you know, what would be happening in the chance that the neuron isn't sending an action potential or isn't trying to communicate through its synapse. Okay. I know that's a lot too, so that's pathways, they do get a bit complicated. That is one thing that I'm happy to cover. I love this pathway a lot. But there are like pathways in the future that do start to get a little bit more complicated. And again, the best way to do it is just kind of to memorize it. And the way I say memorize, is I'm like, if you can draw this out,
Oh, yeah.
drawing is such a good way to be able to memorize it. I've drawn this in like 8 different ways, and the more you draw it, the more you're like, okay, I remember what this shape looks like. And then if you remember the steps on there. I think that's what you did on the last.
That was so helpful.
Mhm. If you draw out the pathway, it really helps you be able to like visualize it.
I found it useful as well. I just re-explain all this stuff to my roommate,
Yeah.
and he hates it,
Teach it
but
to somebody that doesn't know what's happening.
Yeah,
that's like, I got it in my head then.
that way, even if you're wrong, you like have like self-confidence and you're like, that sounds smart.
Yeah. Nobody knows that you're wrong.
Right,
Well, almost no one.
except for Dr.
Only us.
What else? Did you talk about seizures?
Not
Did
the
you
second.
talk about CJ?
We talked
Yeah.
about like, if you have like seizures and like your temporal lobes, that it can like make you aggressive and like change like your emotionality and stuff, and if you
Yeah.
have like a seizure like long enough, it's called some fancy word, and then they'll like separate your.
Status.
Jacksonian
Whatever
March.
that.
So no, Jacksonian March is when it recruits neighboring tissue. She's talking about status
Status
epilepticus.
And so he said that like if you have that, then they help you like a.
Phlebotomy.
Yeah.
Yeah, that's basically.
I don't have a TV in here, otherwise I would show the video.
Yeah.
I swear to God, it's a TV. Next time.
Yeah.
Cool. Yeah, I mean. Any other questions? We've covered I wanna say, I think we've covered almost
Almost
everything
If
that
not almost.
could be on there. And when I say like almost everything, I mean like literally, I don't know any more information. So if you're asking a question,
All the stuff I can think of, I would be blown away if he said.
The phosphatidyl in.
Oh,
Phosphatidyl
phosphatidylainositol. Yeah, so that's the other metabotropic synapse. That's the one that's, so it's inositol, that's phosphatidylainositol gets turned into inositol trisphosphate. And then that gets recycled into phosphatidylainositol, but lithium severs that pathway. Yeah. Did you already have a picture of this, Mary?
I'm like, wait, that's it up. I don't know, and that killed me, that was so funny.
That's when he gets so frustrated, he's like, you have a cheeseburger, you have the cheese.
I know, I love it.
Yeah.
That's what I need.
We've written down quotes of what he said in our class last year, and that is on there.
I have one.
I have a photo of Drew's cards. They're really funny.
I have a picture or a note for our experimental design class and it's growing.
I have a picture of all of the things he said.
I have written down, never accept a transfusion from a prostitute.
There it is.
Never date a statistician.
Yep.
I know he said, show them pornography and see if they pay attention.
That's the enzyme.
That one was the craziest thing I've.
That one was nuts.
Oh.
The camel on Peck Stakes, the camel is a dromedary. He screamed that one out loud.
I knew that one.
Last week, oh, I know you knew that one. Never date a statistician.
You said that.
Yeah, we always talk crap about that one guy, where's the mic?
Yes,
George.
Name drop.
It's like, very interesting, I work for the VA.
I love you swearing, and then all of a sudden he mentions one name, it's like.
As if the mic is like anything.
It's not like he's
recording himself.
I like Zoom, I keep going back to the Zoom where he like gets the rose. Somebody gave him a rose on Valentine's Day and he's like, what are you doing here? And he like waves the rose at the camera. Oh, it was funny. That was my other.
That is very nice.
I love that.
There's, I forget what enzyme is, but it has something probably. I have one and it broke.
A pin of his face.
Yeah, I have a pin of his face, and then literally the part with the pin on it, where his face is on the back other side, ripped off. And so I have a photo of him with no pin and no face.
Oh.
We'll
The
make
rest of his
ones.
body is there. So there's the, what, it's some enzyme, it has something to do with
Oh,
137
no.
trimethylxanthine,
I don't,
which is caffeine.
that's caffeine.
Oh, here it is, okay.
I don't remember this.
You don't remember this?
Well, I do, but I don't remember like the answers to it. I think that it has to do with like, doesn't it have to do with bipolar?
Oh,
Lithium-
phosphodiesterase.
Lithium is helping.
Yeah, so it's a universal inhibitory, or it inhibits all types of, or this type of metabotropic synapse, which causes like universal decrease in CNS activity, which can help with I can't think bipolar, because it kind of just like takes your highs and lows and brings them back.
I
Okay,
think he's gonna ask about this.
I think he did. I think there was like one question.
I don't know.
Did he talk about lithium at all in your class?
Like how it treats bipolar.
Yeah.
Did he talk about
That's all.
how it treats bipolar?
Whoa. Something about salt. He gave an example about how this person.
Yeah, I
takes
remember
salt,
this one.
like salt.
Yeah.
It was his roommate in grad school.
Jackie not just saying this morning about how lithium, oh my god, connection.
Connection,
Holy
right?
shit.
I hate lithium, bro.
Exactly, I was like.
I wish they would stop using it, honestly.
Wow.
It just makes people feel very like
Yeah.
emotionally dead.
One of
and
our
empty.
professors was talking about how it's like one of the most severe.
Yeah, it is. It is.
Things.
It's very hard.
And the guy who was taking it had like explosive diarrhea.
Yes, she's like a forensic psychologist, she knows a thing.
Yeah.
And she was like talking about it, there's this guy on TikTok with bipolar disorder, and I'm like on that side of TikTok, and he's like, yeah, I just quit with you. I don't know. I'm like, oh, everything's connecting.
So,
Once you start learning things, you can like pick it out. It's actually.
yeah. So this is another type, I think this was from last unit, but I'll just say it anyway. So there's another type of metabotropic synapse, you have PI, I'm just not even gonna say the whole name. PI gets turned into IP3 using phosphodiesterase. And then IP3 gets recycled back into, it's like 7 steps. He didn't even tell us what they were when we took the class. You won't need to know them. Gets recycled back into PI. But lithium breaks this pathway. And so there's no molecule to cause this biochemical cascade. So it just shuts off the neuron basically. And so it is a like global CNS depressant. And so like with bipolar, you're like really high highs and really low lows. And it kind of just like, because you have like no activity going on, it just brings them in and just makes you flat.
Well, not necessarily. It makes the highs lower
Yeah,
and the lows lower
eventually.
to a
to
normal degree.
Yeah. Tends towards.
No, because then you don't.
You don't have any emotion.
Mono.
Yeah.
Which it will eventually get to if you just.
You want highs. It means you're happy.
Lithium.
Did you ever watch
Yes.
SpongeBob, like normal Bob, like the round one? Yeah, that's what I'm picturing.
Yeah.
Yeah, kind of.
That's actually exactly.
Do you ever watch Garden State? I really like that movie.
Oh.
They reference Silly.
Yeah, so with a flat line like that, that's why I feel like if you don't feel any highs, any lows,
You're like a robot.
like me.
That one.
But basically, if like this is the intended goal, is it's supposed to reduce these highs and lows, but it oftentimes does just cause unemotionality,
Yeah.
which is bad, but
I have my opinions on it, but.
as he said, there's no such thing as a free lunch.
Yeah, we're just talking about that.
You'll never see a happy snake.
What?
I wrote that down in my exam.
Snakes don't have limbic systems.
No happy snake.
No happy snake.
He called
'Cause he
me out
talked about
too. I showed it to him and he was like, no.
I remember when we did today. Yeah.
You remember this shortcut story?
The short, what?
I'm not repeating it. It's
Wait.
the one where the guy got high in PCP with his girlfriend.
Yes.
Oh, God, yeah. Wait.
If he ever starts off a story talking about a guy getting high on PCP with his girlfriend, close your ears.
You should ask him about it.
It's the most disgusting thing.
Ask him about the story about the PCP.
Writing down.
PCP is like an intense ass drug.
Yeah, say that and then shortcut as well, shortcut syndrome, then you'll
Yeah.
know what you're talking about. We're gonna traumatize them.
Exactly.
It's also called HLS.
Yeah, that's
right.
I can't remember if they were the same.
It's great.
It's us to ask questions.
More just like on this
Terminology.
Yes,
Yeah.
because there's so much covered in this unit, it was gonna be like really basic stuff. Because he's not gonna go in super depth on any of these. The most in depth you'll get is like asking about a specific part in the calcium calmodulin or the calcium to adenylocyclase. So you wanna know that in its entirety, and everything else should be like pretty basic. There's not gonna be any questions like what are the 4 parts of the tegmentum and their functions?
Is he gonna ask how the brain is sliced?
Yeah, probably.
Okay.
He'll ask at least one question about horizontal, transverse, or sagittal
You should
planes.
know the lobes,
Okay.
Yes.
where they are.
Will he be building off of this stuff?
Yeah.
Yes, yes, this is
Oh,
like, this is very
You need to know
fundamental.
all this shit, yeah.
Okay.
You will not hear the end of the substantia nigra. Dopamine is his favorite neurotransmitter as well, so. Cause he said that he told that to the guy who discovered gamma. He was like,
Oh, I remember this.
yeah. There's a story one time he was like, oh, I was working with this like Saudi king, and I'm like, what are you talking about?
I skipped that class quite a bit, it's departmental, but, you know.
I missed it one time because I was sick and I rewatched Zoom and it took 8 minutes for him to talk about me. I was like, he's obsessed.
No, yeah, literally, every time he would be late or gone, where's Vita? Where's Vita?
Where'd he go?
Where's? I still love this.
I know, it's so great. Especially since nobody in that class except for like you get it.
Yeah, I've explained it to Laura, and she was like. I actually, very early last semester, posted a picture of you pointing at the board.
My friend who is from Little Canada
Yeah.
showed me that Abby and I question.
She's like, oh my God, what happened?
I had went to high school.
Overall, really good.
Any questions over here?
I don't think so.
I don't know what else to cover. I think I've gone through all of my notes.
Did we already go over the Olympic system?
Yep.
Yeah.
Yeah, we kind of just talked about it.
For the low of the brain, do we just need to know the four, do we even know about each one?
Just,
No, like, if you can know a general information, do it.
Yep.
A brief description, I would know what they are at the very minimum.
I'll do like a really brief.
Yeah.
Did you talk about, damage to your visual system and scotomas?
I think that'll be on the exam.
I
The
said,
last one, I was thoroughly shocked the last test, like, I feel like I was gonna throw up during the test. I was writing down, I had to look at them.
I felt really ready to get that.
You guys also talk about the stuff that you talked about. Or no,
How many meetings?
like from your Monday review session.
oh, I didn't even
Yeah,
know there was
we,
one on Monday.
we've covered, like
Oh,
a
yeah,
good majority of
yesterday.
the stuff that we covered on Monday. If not, probably a little better.
I was literally there yesterday, wasn't I? Yesterday was Monday. I condensed all of it into a PDF that's posted on the announcements page, but we also covered all of that in this session.
Yeah, if we haven't, then it should be
Yeah.
available on Canvas or just email me.
There's a picture of a board, because we have a much bigger board. There's a link to the brain facts 3D brain model on there. And I kind of formatted it as questions instead of just statements. So like, what does the thalamus do? What does the hypothalamus do? Some of them are definitions, but
So that's a really rough dissection of the four lobes. I can't think of really what the frontal lobe, besides like somatosensory, because this is like the primary somatosensory cortex, and here's like association areas. It's like the wear pathway. That's like all I really know about it. The parietal lobe is like I don't know, he talked about how it's like not really a lobe. It doesn't like have
yeah.
any like really big notable function, except for like it has the primary and associated somatosensory areas.
That's pretty.
Yeah. Same reviews of, if you have questions later, email me, no matter how
Yeah.
simple. I literally will probably respond at latest within a half of a day. If you email at me, if you email me at night, that's cheating, I don't. Maybe it depends. But, yeah, like if you email me at night, expect to reply in the morning. I know I sent a like announcement out for these things at like 9 p.m. and I was like, I hope this doesn't scare the crap out of people.
I also obsessively check my email, so I will reply really quick, but
I get,
after 10 p.m. I'm asleep.
I get
So
notifications about emails, but I tend to read something and then immediately forget about it. So I will do my best to condense this. This is a lot of stuff.
Yeah.
yes.
At the latest by tomorrow, before like 24 hours before you test. I'll try my best.